Okay, so I took her up all the way up to 15.18 or something like that, and I was going to continue, and I wanted to actually get it so that it was really quite bubbling. I mean, it was bubbling, but not a lot. And then something packed it in on my circuit, and so far I've tested my power supply. It looks like it's okay, so I think something went wrong with my charger. So I'm going to have to check into that. So then I loaded it, and it's running 4.5 amps right now, and of course it quickly dropped down. It's been going for about 4 minutes on that 50-watt light, and it's still falling. So we'll see. I'm gonna stop this video, and we'll see what it levels to, what it runs at. Remember last time it was running on its plateau at about, I think it was something like 11.3. It was pretty low. I think 11, between 11.4 and 11.5. So it would be neat to see if we could get it to run at 11.8 or something. Alright, I'll come back to this. Okay, so here I am an hour later of running a 50-watt load. Now, if you see my previous videos, you'd be like, holy crap, that's great. But you know what? I discovered something. My numbers on my last run, when I first ran the load on this battery, were relatively inaccurate. And that's because, well, I don't know exactly what, alright, but it's showing running at, see, if you look, I'm pressing deeply into the lead compound now, and I didn't clean up these battery connections really well, which was, you know, kind of dumb, but I was in a hurry. And see, if I just touch these, okay, let's say something like that, alright. I don't quite understand why. I mean, those are 10 gauge wires connected to my light, and those are the clips for the wires, let's say. Alright, but even if I drive it into the threaded post, well, I don't think I can do this one-handed, but the point is, my numbers were a little out of whack, because if I go like this, I'm going to lay it on these clips, trying to press a fair bit. That's what I get. Obviously my leads are reversed, but you can see it's quite a bit higher. So who really knows what it was running at before and how bad off it was in the beginning. That's unfortunate. And my circuit packed it in, so I don't know. But the good news is, one indication though, is that it's actually, it's hard to show you, but it's pulling closer to 4.3 amps after an hour. And it's sitting at a 12.4 running the load. But like I say, I don't know what it was before now, really, truly. So, really hard to say. Apologize for wasting your time. Okay, so as I said, this experiment has been kind of botched. Alright. And that's unfortunate, but what is fortunate for me is that the battery is looking really good. And I'm going to have to be a little bit more careful with round 2 of this when I get this fixed, and we'll have a look. But it is my belief that it has done something. Okay, it has improved this battery quite a bit. Okay, and I'm going to show you something here. You gotta understand that this ran for 3 days, okay, with no more than 2 amps input at any point. All right. Then what happened was, so you know, you have like 64 hours at 2 amps, even though it wasn't 2 amps, but we'll call it that. All right, so maybe 128 amp hours of input to this battery. I run it up to 15.2, immediately loaded it with 50 watts, ran 50 watts for an hour. It maintained 12.4. Now, I've had the load disconnected for a half an hour, and it's recovered to 12.71. So we're not talking about a surface charge here anymore. In my belief, a 50 watt load is enough to burn off a surface charge. I could be wrong on that, but so there you have it. You know, like, I mean, it's I mean, it's possible that the battery was perfectly okay in a sense that it just needed equalization. And, you know, so few people equalize batteries, period. And I think every bit as much, like, the gray area is that desulphation and equalization are to a great degree the same thing in my mind. And the benefit of, say, an SSG or as a TSO is even better, in my opinion, is that you can equalize for long periods of time with low amperage. And when you read about equalization, they talk about using a fair amount of amperage, and they really do get the thing boiling. And they talk about battery temperature too. You know, they say, well, the battery's got to come up to 104 degrees to properly equalize. Well, I'm in Canada. I mean, it's 40 degrees out here and has been since I started this experiment. So, you know, it's not warm out by any means. And so I'm sorry that this experiment botched up. But you know what, we're gonna do this again, and the good news is this $15 battery just ran a 50 watt load for an hour to burn off the surface charge, and it maintained the load at 12.4, and it's recovered to 12.72. So certainly not looking like a completely done battery by any means. So we'll see how it goes. I'm gonna see if I can run this. I'm going to run this thing down and see how many hours I get out of a 50 watt load. Alrighty, thanks for watching. Sorry for the screw up there. Lesson learned, clean up your battery posts really well. Oh, and the other thing, these stupid little things here, you know, if you use them to connect your voltmeter to your battery out of convenience, I got 0.9 ohms of resistance in one of them, and I got a 1.1 ohms of a resistance in the other croc. So, and you know, even the cables on the frickin' meter are coming up with a bit of resistance. So, lesson learned there, you know. And this is at 12 volts. Imagine if we were experimenting with 1 volt batteries, how relevant that would be. Alright, talk to you later. Thanks.